Hey folks, welcome to our next calculus lesson. So by this point you've read section 10.4 on minimal path problems, and we're going to do a couple of problems here. So generally, I looked it up, the average human walking speed is about 3.1 miles per hour, and the average Olympian swimmer speed is 2.06 miles an hour. So you and me walking along the side of a pool would generally be faster than even an Olympian swimmer who has trained their entire lives swimming in the pool. There are, of course, notable exceptions to this, and some swimming strokes are faster than other swimming strokes. For instance, Michael Phelps has the world's top speed of 5.5 miles an hour. He also has 8 gold medals from a single Olympics, so he's pretty famous. But hey, we're not comparing ourselves to Michael Phelps, though there is a funny commercial on Hulu that does compare someone to Michael Phelps. Enough incoherent rambling. Let's take a look at some calculus. So this is our aim. How do we find a path that minimizes total time or cost? And here's our first example. Phoebe's in her canoe 3 miles from the nearest point on the shore of Lake Erie. She wants to get to her campsite 5 miles from that same nearest point as quickly as possible because she is hungry. She can row her canoe 2 miles an hour and walk 4 miles an hour. How far from the nearest point should Phoebe head in order to minimize her trip? I should have changed it to be Mr. Mendelson. Anyway, a diagram helps out, so let's draw one. Okay. Phoebe, nearest point, campsite, 3 miles, 5 miles, and this is going to be the point she wants to head to. So let's call this, I don't know, W for wants to head to. We want to figure out how far from the nearest point should Phoebe head to in order to minimize her trip. So that's going to be this distance from N to W. And then that means that this distance from W to C is just the whole thing 5 minus X. Cool. Now, you've probably seen in other science and math classes, distance equals rate times time. It's a pretty common formula. And if we want to solve for time, well, we just divide both sides by r. So distance divided by rate equals t. You could also write it as 1 over r times distance equals t, time. And this is what we're going to be using with the information we have given. Now, the distance that Phoebe is going to be going from here to here is 3, from here to here it's x, and then the time is just given by, the rate is given by our problem. We have 2 miles an hour and 4 miles an hour. So if I wanted to find this length, well, this is a right triangle. So Pythagorean theorem tells me this is just going to be 9 plus x squared. That's going to be my Pythagorean theorem. So this she's canoeing, so it's going to be her canoe speed, or 1 over her canoe speed. So 1 over 2 times the square root of 9 plus x squared. And then that's going to be plus her walking speed. That's going to be this part right here. And her walking speed is 4, so it's boom. And that's how long it's going to take her. That's the total t. Well, we need to find the derivative. Once we find that derivative, set it equal to 0, and we solve. So let's go for it. That's the derivative. Chain rule was used over here. This is simple power rule. We can clean that up a bit. Cool. Now we're going to want to set this equal to 0 and solve. Well, if I set that equal to 0, this is what I get. Okay. Let me explain a bit of the algebra that went on here simply because I skipped a few steps for the sake of time. Moved the fraction over, multiplied both sides by 2 and by x. Moved this over to the other side. Notice this is now positive because this was a negative, so I just multiplied it on both sides, now it's a positive. Squared both sides, solved using factoring, quadratic formula, whatever you want, and this. Now, we know that our answer has to be between 0 and 5. One of these is a negative number. So that means that our x here is equal to positive square root of 3. That's how far from the nearest point Phoebe should aim. And let's check that by graphing. So I'm on Desmos's calculator up here. I've typed in our time equation. I've typed in the original, not the derivative. And if we just graph this out and click it, Desmos is actually kind enough to put a point at any intercepts and also a point at the minimum. So over here, it's at 1.732, and actually, if we do the square root of 3, it's 1.732. So we've just graphically verified what we found using our calculus. Cool, so now you have a nice way of checking and knowing if you're right. You can just do it graphically. So go ahead and give those 3 problems a shot. The odds are classwork, and you can just check them out. The others are homework. I forget if I switched that, but whatever, I'm not going to go back and check. Remember, you're just setting up a diagram for all of these, and you're using a really similar process. If you have any problems, let me know in office hours, send me an email, add a comment, anything like that. We'll be continuing with this topic next time as well, and we're going to see a slightly different way of doing it too. So until then, stay safe, folks. Hope to talk to you soon.